Alright, now that we've successfully created a footprint for the MSOP package for this, this part, the SSM2167, let's build the next phase of it, which is the schematic symbol. And again, we will do that within the library of Eagle. So we were here in the package, the footprint builder, which was this second button here. And now we'll move to the third button, which is the schematic symbol. Okay. And what name you give it is up to you, but I usually give it some sort of prefix. So I'll call this compressor dash underscore whatever. You can't use a space. SSM 2167. Would you like to create a new symbol? Yes, of course we will. Alright, so our goal is to translate in some useful way all of these pins into something that makes schematic sense. We have the opportunity with a schematic symbol to reorganize these pins and group them and do anything that we want to make the schematic a little more understandable. And remember, we could very easily do everything exactly in the way that it's viewed here, starting with pin 1, the ground pin, and moving on around the edge and everything like that. And that would be perfectly legitimate, and many people do it that way. I particularly like to see schematics, and when I read a schematic, I would like to get to the point, right? So organizing the information in a schematic is important to me, and so I will reorganize these pins in a way that makes the schematic flow better. That's just me, because most of the time I'm the one who has to deal with my schematics. So what I'm going to do is I'm going to try to get both of these on the screen at the same time, because one of the first phases that I will have to deal with is making sure all the pins are actually present and accounted for. Alright, so here's my schematic symbol. We didn't talk much about it in the last segment, but the origin is usually this little dot here, although you can have a reference or a relative origin that might be floating out in space. So when in doubt, put your mouse over it and see what the coordinates up in the top say. So this is 0, 0. That's good. That will be the insertion point if you've ever worked with blocks in AutoCAD or anything else that has these kind of schematic symbol type of things. This will be the insertion point for that. And so I will almost always put that as the first interesting pin. Okay. I'm not really all that interested in the unit of measure that I use. I'm going to stick with inches, and I've got a grid of 0.1 inch. I almost always use that all the time, so that's cool. This is very simple to do what you want to do in creating a schematic symbol, which is nice because that means you can focus most of your effort on making a organizationally useful part. So here are our pins that we have to deal with, and each one of these pins must exist on our schematic symbol. We could split up the part, the SSM2167, into multiple schematic symbols if we wanted to, and when we get into the microprocessor of this project, that's probably what we will do. But for this one, everything can go on a single symbol, so that will simplify things quite a bit. So our bread and butter is this command right here, which is called pin. You could type in the word pin, or you could just click on it, whatever you'd like to do. Okay? And with pin, I'm going to stretch this out just a little bit so we see the whole range of options that we have. We have a lot of different stuff going on to make this pin look the way that we want to do. The first one is what the orientation is, right, which I can right-click and cycle through my orientations. Note that this only has 90-degree orientations. Cool. I can have kind of ancillary schematic decorations on a pin. So here's nothing. This is a dot, which is often used for an inverted logic if you're using a logic component, a triangle, which is used for clocks, and a dot clock, which would be obviously an inverted clock. Okay, so those are available for us to use if we need them, and we won't in this one, so I'm going to go back to none. Okay, then we have the pin length. We have it as a point, a short line, a medium line, a long line, right? I almost always use short lines for this. Occasionally when I'm doing things like transistors or op amps that have something strange going on, then that might be a little bit different. So, all right. And lastly, the visibility. Nothing is visible, which means it's just a pin. I only want the pad, so I won't see much happen here in this if I only have pad on, because pad is a attribute that only shows up when we go to connecting a fully complete part. In other words, a connection of a schematic symbol and a package or footprint, and pin name only, and both. Okay, so I'm going to use both for this one because I want to see the pin names on my schematic. We have a direction pin that I don't use very often. I may just talk a little bit more about that in another segment, but for right now I'll use the passive. This can be used in what we call electrical rule checks, where I can make sure some rules like inputs are always connected to outputs, or two outputs are not connected to together, or so on like that. The most generic one is the is the passive one. The power one we'll talk about in a later segment as we get into building some other parts and stuff. And then finally, swap level. This is where you might decide to swap two pins later on. And this is really useful for resistors, where you realize that my layout flows better, my schematic flows better if I were to just simply flip that. And since resistors don't really have a direction to them, then we're perfectly fine to do any amount of flipping that we want to make things flow better. But for right now, swap level 0 means there is no swapping available. So now we have it, and let me scrunch everything back. So we have our settings that we want, and let's start with our first pin, which is called ground. Now, ground is a commonly used term, obviously. Lots of pins have multiple grounds, and so we want the ability to just call everything ground, but Eagle requires things to have unique pin names. So I'm going to call it, I'm going to give it a name, and the name will be called, names and text labels begin with a tick, just like kind of in Excel or something like that. They don't have to end with a tick. So they just tell Eagle, this is text, it's not a coordinate or any other things like that. The command line structure is a little funky in Eagle, but you get used to it after a while. Anyway, tick for name, and the name will be called ground. Capitals, ground. I'm going to use the @ symbol, 1. Now what did I just do there? It's not called ground @ 1, it's called ground. But what I did was told Eagle you should display the word ground, and then the @ symbol tells it to stop displaying things after this point. So I could have ground @ 1, ground @ 2, ground @ 3, and when they display, they will always be called ground. So let's just go ahead and no one else really has this problem, so I'm not too terribly worried. So I'm going to start with it here. Whoops, I forgot to hit enter. Tick ground @ 1. Enter. There we go. And now it's called that. Okay, great. My next one is going to be called VCA in. I don't really have a subscript command in Eagle, so I'm just going to call it with an underscore. No ats, because I never envisioned that ever going anywhere. Oops. That's what happens when you don't begin with a tick. You thought it was an option. Okay. Now shutdown has an overbar. So in Eagle, that's a exclamation point. And I could exclamation point it again to turn back the overbar back off. Okay. Buff out. Yeah, see, that's what happens. Okay, and input. Tick input. Okay, great. The other side is going to be tick average AVG cap. Tick gate thresh. I'm going to shorten this one to just call it ratio. That was too much words. Output. And I'm going to do another one of these with the @ symbol, VDD @ 1. It's just a good habit to get into, even though this one's really simple. Okay. So here's all my stuff, but it's not in a very good order. So let's start moving things around. But at least I've captured everything, right? Grounds are going to go at the bottom. Power supplies are going to go up at the top. And I'm going to orient everything to the right. I want it to flow left to right. I want my VCA in and my average cap to be close to each other. I want my input to be kind of front and center. I'm going to shove a few things around. Start putting some things together. One thing that can help this quite a bit is if you look in a manufacturer's data sheet and see if they've got an application circuit or an example circuit, like this one. And you start to see how things kind of are naturally organized. They have things in sort of a strange order that I don't think I like. So, you know, whatever. But I do notice that I have to have the average cap and the VCA in should be close to each other. I think that's the right pinning. Yeah, this is probably a better one. Buff out and VCA in. So those should be close to each other. Okay. We'll put all of our settings over here. So things are set by these 3 pins. Ratio, average cap, and threshold. So this is kind of where I do my settings. Kind of separate things out a little bit. Give a little space because I know that I need to have a little bit of a capacitive loop between there, so I'm going to have to put a capacitor in there. And my ground. Now, I'm not liking how ground is going here. Let's go sideways. I might have turned off the visibility for ground and VDD if I didn't like them like that, but it's doing okay. I'm alright with this. Sure. Okay. Boom. Maybe. I'm playing this stuff a little bit here. I don't really know where to put shut down. Well, I do know. Because I'm not going to ever shut this thing down, I'm going to put it near ground. Because why not? Yeah. And now I've gained a little bit of space here for some breathing room. As you get into building this, you might find that you want to build space around here because I want to put a capacitor right next to it vertically, and I don't want to kind of expand back out and come back around or do something like that. So this is a little bit of, you know, kind of how you got to find out what you like. All right, cool. Now let's make a box around this. It's pretty standard. And all the stuff that happens on the symbols layers, on the symbols, is going to be on the symbols layer. So that's nice. Turn on the 90-degree cornering. Okay, so I got a box around it. Finally, I need to make sure I put my macros on there. So text. And here we're free to, you know, we got to do some cleanup because it remembers a lot of settings from before. But our first one is going to be name. We always want to have the reference designator. Okay. And you also notice it kept some settings from before in the footprint layout program. So let's get back. Eagle's kind of standard is about 0.7 for everything. I don't care about ratio, and I do want to make sure that I'm using the proportional font so it looks nice. But I don't want to put that on the symbols layer. I want to organize my thing. Eagle gives me a names layer, so that's good. And you also notice that I don't really like how the new version of Eagle has a center justify and stuff like that, so I do a little bit of funky stuff here to just sort of have it float around with a little margin around it. Okay, so cool. All right, last, this is something that I like to do a lot because I'm big into organizing my information and helping myself out wherever I can. Every time I build a part, and we'll see this a little later, I create 4 or 5 extra macros or attributes that I can use. I don't have to, name is not the only attribute or macro that I can use. I can use any attribute, including the custom ones. I will be creating a couple more custom ones on there. And one of them is called MFG for manufacturer. I usually put those at the bottom. I'm just changing the origin of this thing. Like say, New Eagle has a center origin. I really wish I had that, you know, but whatever. And I'm not going to put it on the names. I use a layer called info. I probably should make my own, but whatever. You should definitely. So manufacturer and MPN, manufacturer's part number. They all begin with the greater than symbol, which means that they are all macro expanded to be whatever those attributes are. Okay, great. Do a quick quality assurance check. Do I have all my pins? I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Good, 10 pins. I have my name manufacturer part numbers. Everything looks good. This schematic symbol is now complete. So that concludes that portion of this.